Optimisation mathematics helped Kiwi rowers Kevin Bigger and Jamie Fitzgerald win a transatlantic rowing race in 2003. The Woodvale Transatlantic Challenge is a grueling event lasting over 40 days. Pairs of rowers in identical kit-set boats battle the elements and their own fatigue to row from the Canary Islands off North Africa across the Atlantic to the Caribbean island of Barbados.
I get asked a lot about why I did the race, and it's kind of a tough question. I was going through a time in my life when I really felt that I was 33 years old and felt like I was 63. I just felt like my life was almost over, and I had one more chance to try and achieve anything that I dreamt that I would do when I was younger.
It's day 5. It's 12:30. We are still making our way down southwest.
So we had identified before the start of the race as part of our preparations that it was absolutely essential for us to have a very smart routing system. You can put a lot of time and energy and effort into making the boat light, or to getting the most expensive piece of equipment that might provide you with a fraction of a knot advantage. But if we could just somehow take, say, 50 miles off the route that we took in the course, then we could save a whole day when we were out there. The options that we had were really to just try and copy what the routes other boats had used in the past, particularly the route that Rob Hamill and Phil Stubbs took in '97. That's obviously a very static thing, and it doesn't give us any advice about what to do if we didn't have exactly the same weather that those guys had. The other option, I guess, would have been to go to a yachting optimization piece of software, or to an expert, because there are lots of people for yacht races who provide information and optimizations of the best route that yachts and yacht races should take. But we weren't a yacht, though. The big advantage that yachts have is that they move at a pace that can keep with the weather systems, and we pretty much just could take the weather that blew over the top of us. So we had a slightly different optimization problem, which is what eventually led us to go to the University of Auckland and speak to Jeff and Andy.
The race didn't allow any outside assistance, and at the time we embarked on this, we believed there wasn't any computers allowed on the boats. So we had to come up with a very low-tech solution.
Well, end of day 7. Looks like we're in for another big night.
As events transpired, the boats did have computers on them, but battery power was very limited, and we didn't want to rely on a computer to make what would be very important decisions.
Well, because we couldn't do any live routing while Kevin was racing, we had to go back to historic data and get the hydrographic charts from the UK Hydrographic Office and use them. These charts show us observations of wind across the Atlantic for the last 20 years. So this windrose shows the prevailing winds in the area. The larger lines on the right of the windrose show that there's a prevailing east-northeasterly flow. We also have the ocean currents, which have a huge effect on the boat's navigation.
Now we've been becalmed for 2 days at seas like this. Every day it's getting calmer, it seems. Waiting for that nor'easter to kick in. That's going to get us to the finish line.
Here we have the grid that we placed across the Atlantic, and we use the dynamic programming technique to get from that to this isochrone map, where we have a line that's 1 day from the end of the race, 1 week from the end of the race, all the way to 41 days from the end of the race, right back at the start, if you're doing a world record time.
6,622 green bottles sitting off the wall.
We gave the rowers a copy of the overall map and 6 copies of blow-ups of each area of the map to use each day. We laminated them, we gave them 2 or 3 copies, and made sure that you could write on the maps with indelible pens so that they were absolutely indestructible for the whole race.
Raining, falling off containers, oil tankers.
When we showed Kevin the maps, he said, I really wanted a route rather than a map. But we brought up the case of a boat in the previous race that had been blown off course and then tried to get back to what they thought the optimal route was and wasted a lot of time. What they really needed was a policy that said, if you're in this part of the ocean and the wind is doing this, you should row in this direction. And that can adapt to different conditions as you see them. It can also adapt to being blown off course.
There's the full moon out.
The isochrones give the rowers a policy in the following way. At any point in the ocean, they can look at the map and see what the next isochrone is and treat that as a finish line. so they can row as if that's the finish line for their race. This works irrespective of what wind they're seeing and where they are in the race. Once they reach that isochrone on the map, they then re-look at their speed and look at the next isochrone. That then gives them the finish line for the next day. So if a boat is sitting at this location here on the map, they can row in different directions shown by these red arrows. This red arrow here takes them away from the next line. This one here takes them to the next line in the shortest possible time. So they choose this intermediate direction rather than the other two, and then they start again once they reach that point to try and get to the next line, and so on to the finish.
So we would use the map each shift. Certainly each day we would start out and we would check where the wind was coming from, and then try slightly different angles to see how we could optimize our speed to get to the next isochrone. I think in retrospect, one of the biggest advantages that the isochrone map gave to us was during those 2 days we had the headwinds, because those were the 2 days that we made the biggest jump on the rest of the fleet. And thinking back and trying to put myself into those other boats, I could see, I think now that when they had a wind that was coming from the direction that they thought they had to go, then psychologically it gets very tough for them to try and do anything else but put their sea anchor out. For us, the big advantage that we had from having the isochrone map was that we had choices then. We could see that we could either put the sea anchor out and see how far back we were sliding, or we could try and take a slightly different route. And the isochrone map could show us that we could head west, for example, and that would mean that we would be making some progress. And once the winds had gone, then we could capitalise on that. It just gave us options.
The change of lead on day 32 led to a protest claiming that they had moved faster than humanly possible by rowing, and they must have been using a sail or something like that. But we'd been analysing the race very carefully with our maps, and we knew that at no stage had they gone faster than we expected them to, or faster than they possibly could have. So our analysis of the race showed that Holiday Shop made their best progress on days 2 and 32 when they rode into the headwinds. We were also able to show that they didn't have the highest speed of the teams in the race, and in fact the protest boat had gone faster than them at one stage of the race, as had several other of the boats in the race.
So it's the 23rd of November, it's a Sunday, 1:10 and we're in a bit of a squall, but the winds are very good. It's bang on where we want to go, 260 degrees, heading straight towards the finish line.
The hardest bits to deal with in the race was the heat. It just got so hot during each day, and you just found yourself, it's just so hard to put any physical effort in when you feel like you're melting. In terms of the most dramatic moment was when we capsized just a couple of days out from the end, and getting tossed into the water at night time was just absolutely horrifying, and something I hope we'll never have to go through again.
9,962 green bottles.
This was a fantastic application of mathematics. It really brought the subject alive for me in terms of applying it to a real problem. I've spoken about this to many academics around the world, and they're fascinated by the application and the way that mathematics made a big difference to this problem.
I think one of the most interesting challenges was getting something that they could use on the boat. Andy and I started off thinking about they'd need a computer on the boat, we'd need to have communication with them, we'd have to look at the weather reports every day. And there was a real moment when we finally worked out that we could give them something better than any of those solutions, but that used something really low-tech and robust.
I agree, it was fantastic, and they used it and they won. That's the best part.
So here we are at day 40 of the trip, and last night around 3 AM we started to see the lights in the distance of Barbados, and after rowing through some pretty horrendous seas, I think in terms of rowing awkwardness, it's one of the worst seas we've been through. No stars, no moon, big old swells willing to pounce upon you in all directions. We finally made it through the night, and if Jamie does a pan, that's where we're heading towards.